Sai Ram class, how are you all? I hope that you all are very fine. So class, as we were in our workbook and we are doing the last chapter for this session, that is chapter number 13, Fields and Fences. We had already done till question number 5. Now today we will start from question number 6. So question number 6 is, it is an application based questions. So the first part is, the length of 3 sticks are 18 centimeter, 9 centimeter and 20 centimeter. Whether he used these sticks to form a triangle, means whether he used these 3 sticks to form a triangle. Suppose this is that triangle. So one of its side is of 18 centimeter, one of its side is of 19 centimeter and the third side is of 20 centimeter. So the question is, find the length of the boundary of this triangle. So what we have to do to find the length of its boundary, we have to add all these 3 sides, that is 18 centimeter, 19 centimeter and 20 centimeter. So let's see the solution. So the solution is, length of the boundary of this triangle is 18 plus 19 plus 20 centimeter, that is 57 centimeter. Now the next question is, look at the picture of the tablecloth. This is the picture of a tablecloth and find how much lace is used for one tablecloth. We all know that the boundary, you can see the design on the boundary of this tablecloth. This is the picture of lace. So that means we have to find the length of the lace starting from here to again here, means covering the boundary of the cloth. So indirectly we have to find the length of the boundary of this tablecloth, and we have given that the length of the tablecloth is 3 meter 40 centimeter and its width is 80 centimeter. And after which we also have to find how much lace will be left in the roll if the roll is of 20 meter long. So let's first find out the length of lace used for one tablecloth. So for this you can see here, lace length used for one tablecloth is 2 into 80 centimeter. Why we are multiplying 80 centimeter with 2? Because we have 2 width here. So we have to multiply one width twice. Okay, so that 80 centimeter add on with 80 centimeter, means we can add 80 with 80, or what we can do, we can directly multiply 80 with 2. In both the cases we got the same answer. And the same thing we have to do with length. We have to multiply length with 2 so that these two lengths will be added with the width. So you can see here, 2 into 80 centimeter, we have 160 centimeter, and 2 into 3 meter 40 centimeter will be equals to 6 meter 80 centimeter. Now we have to multiply meter with meter and centimeter with centimeter. So you can see here, 160 centimeter means we have 1 meter and 60 centimeter. So this 1 meter will be added with this 6 meter and this 60 centimeter will added with this 80 centimeter. So you can see here we have 7 meter plus 140 centimeter as answer. Now again 7 meter and 140 centimeter. That means in this we have 1 meter and 40 centimeter. So this 1 meter will add with 7 meter. So it will become 8 meter 40 centimeter. So this is our answer. Answer is 8 meter 40 centimeter. Now the second part of this question is also find how much lace will be left in the roll if the roll is of 20 meter long. So we all know that only 8 meter 40 centimeter is used for one tablecloth. So out of 20 meter, when we have to minus 8 meter 40 centimeter for this tablecloth, then how much lace will be left? For this we have to minus 8 meter 40 centimeter out of 20 meter. So you can see here we have how much left? We have to minus it. So when we do this subtraction, let's do it in rough. That is 20 meter 00 centimeter, 8 meter and 40 centimeter. So let's subtract it. So it will become 1, 10. Then this gave it to 1, it will become 10, it will become 9. And it gave it to 1, it will become 10, it will become 9. Now 10 minus 0 will be 10. So it will again become 10. Now 10 minus 4 will become 6. 9 minus 8 will become 1 and 1. So we have 11 meter 60 centimeter as answer. Okay. That means 11 meter 60 centimeter lace will left out. Now let's move on to the third part. A square park has side 140 meter long. How much wire will be required for fencing around it 3 times? Now we have given that there is a square park. Means a square who has all the 4 sides equals and it has side of 140 meter. That means 140, we have to multiply 140 with 4 to get the total boundary of this square park. After which we have to answer how much wire will be required for fencing it 3 times. Okay, that means we have to multiply its boundary with 3 to get the length of the wire for fencing. Let's see how we have to do it. Length of wire required for fencing one round, only one round. So it will be equal to the boundary of the square park, that is 4 into 140. Okay. Now the length required for 3 times fencing. For this we have to multiply its 1 time fencing with 3. So you can see here after multiplying these we have answer 1680 meter. That means 1680 meter of wire will be needed for fencing this square park 3 times. Now the fourth part is Mihika took 2 rounds of a rectangular park. You can see this picture of that rectangular park having length 120 meter and width 40 meter. Now Mihika took 2 round of this rectangular park, means 1 round that is equal to the perimeter of this park, and then again 1 more round that is 2 into perimeter of this park. Now the question is we have to find the distance covered by Mihika in all. So that means first we have to find out the length of the boundary of this rectangular park by multiplying its length 2 times and then add the multiplication of width 2 times. So that is this. We have a formula for perimeter of rectangle is 2 into L plus B. Now this is the distance for 1 round only. Now to find out the distance for 2 round we have to multiply 2 into L plus B with 2. So it will become 4 into L plus B. Now we have to put the value of length and breadth and we get our answer. You can see here 4 into L, that is 120, and breadth that is 40 meter. So 120 plus 40 will become 160 meter, and when we multiply 160 with 4, we have a sum of 640 meter. So that means Mahika covered 640 meter distance in total. Now the next question is, if some part of the original figure is cut off, then find the length of the boundary of the figure which is being cut off from the original figure. You can see these figures. This is the question same as we did in textbook. So this is the original figure, and this one square is cut off from this original figure. Then the length of the boundary of cut off figure is, you can see here, this is the cut off figure. Okay, so we have to answer the boundary of this figure. So you can see here, this is a single square with all the side of 1 centimeter. So the boundary of cutoff figure is 4 centimeter, and this is the boundary of remaining figure. As you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so we are writing both the boundaries, that is of cutoff figure and of remaining part also. Now same for the second one. This is the cutoff figure. So let's count its boundary. 1, 2, 3, 4, 5, 6 and 7. Sorry. 1, 2, 3, 4, 5, 6, 7 and 8. And the boundary of remaining part is, let's count it. 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay. Same we have to do for last part. 1, 2, 3, 4, 5, 6 is the boundary of cutoff figure, and 4 plus 4 plus 4, that is 12. 13, 14, 15, 16, 17, 18 is the boundary of remaining figure. Okay class, so this is just simple questions. Now let's move on to the last question for today's class, that is question number 8. Name number of squares. So the first part is, see the following figure and then answer the given questions. So this is the question. This is the same as we did in textbook. Okay, so let's count the number of boxes vertically and horizontally. So 1, 2, 3, 4, 5, 6 and 7 square. Similarly 1, 2, 3, 4, 5, 6 and 7 square. So the question is, how many small square of size 1 centimeter are there in this big square? So when we count them, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. Now they are asking, is there any other way to find the total number of square without counting each? If yes, then write. So this is the second way, without counting it. So for this, what we can do? We have to just multiply the number of square horizontally with number of square vertically. That is 7 into 7, and we have a total 49 squares. As you can see, by counting and by direct multiplication, in both the cases we got the same answer. Okay. Now the second part is, guess how many more squares of 1 centimeter are required to fill this rectangle. So let's first count the total squares. The number of total squares should be, so you can see here, 1, 2, 3, 4, 5, 6. It should be 6. 1, 2, 3, 4, 5, 6, or could be 7. Okay. Let's assume it at 6, and 1, 2, 3, 4 and 5 in this way. So 6 into 4 is 24. Visible is 18. Visible means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Visible squares are 18. So the required squares are 24 minus 18, that is 6 squares. Okay. Or if we consider it as 1, 2, 3, 4, 5 and 6 and 7, then it should be 7 into 4, that is 28. Then the required square will be 28 minus 18, that is 10. Okay. So this is it for today. Practice all this question in your workbook by your own, and we will meet in our next video. Thank you, class.